All right. Yeah, cool. I think it's going. So we're going to finish up chapter 3 on branches today. We got a lot of stuff we went through really quick. We got a lot of material. Uh, so again, just sort of as a check for you here, if you're keeping track of time, um, it's about 12 hours a week worth of effort. Kind of keep that in your back pocket, right? As a 4 credit class, 4 hours ish or so in person, 8 hours outside, doing your readings, doing your homework, doing your projects, doing your stuff here. How'd everything go with lab on Monday? I did not make it to stay. Sorry, my earlier class finished up early, and I was like, "Do I want to sit here for an hour?" And no, I didn't want to sit there for an hour. So my apologies. So I generally won't see you for labs unless my earlier lab in the day runs late. Uh, did it go okay? Maybe. Okay, not too bad. All right, cool. So I'll chat with Dr. Saeed, see if he needs anything from me. But I gave him previous labs I've done before. I don't know if he's going to make his own labs or use mine. And it should be a lot of fun. So you'll get the joy of having two different people you have to work with. You'll have to do all the stuff I want, the way I want you to do it, and you'll have to do all the stuff the way he wants you to do it. Um, but it shouldn't be too bad, right? Generally, the philosophy with the labs is if you show up and you try, you should be able to get them done. Right? They're not meant to be crazy hard. That's your chance to practice and get it done when someone can answer your questions, and we can stop and see what's happening in your computer. Is that hopefully that was your experience on that? That's ideally how those things go. As our friend said, forgot her name already. I just get hundreds of new names every semester, and I'm terrible at remembering them. My apologies. I don't remember what her name was from the Engineering Learning Center, but they're fantastic. Um, go and get help if you need it, and ask me. I'm happy to help. Ask Dr. Saeed. He's happy to help. Ask your SI. They're happy to help. Go and talk to a tutor one-on-one. They're happy to help. The, I've sort of struggled a little bit with this class and then how many people fail the class because I feel like between me and the lab instructor and the SI and the individual tutors and everything available, you should not fail. And yet people keep failing. And it's a little depressing because I feel like if you just put the time, energy, and effort in, you'll get there. You know, maybe you get there and you realize, yeah, this sucks. I don't want to do this as my major. That's okay. I won't be personally offended if you change majors here. But I think people should pass 150 in general. Like if you're going to put the time in, you've got people who are going to help you pass. All right. But if you just sort of fall off and don't ask for help, and then you come around to the final project time and you're like, oh, I haven't done anything for 12 weeks because I gave up and just sort of sat there quietly, there's no chance there. Right. So you got to put the time in every week here. And if you get behind, we're here to help. We got resources to help. I can meet you with you. Like we got options. So just let me know. Uh, it should go relatively well for you. Again, it's not hard material, but it's a lot of material, and a lot of people will tell you it's like learning a new language. So I'm sure there's a lot of you in the room who are smarter than I am and can speak more than one language. I barely made my way through French in high school just to get the credits I needed to graduate. And then I ended up in France 10, 15 years later, and honestly didn't even remember how to say anything more than hello. That was all I had after 2 years of French in high school. And I sucked at learning another language. But I didn't practice. Like, I had my class, and that was it. I never tried outside of it, and I didn't retain any of it. So if you think this is something you want to make your career out of and get into doing computer science work and programming work, you got to practice it to get good at it here. Did I ask you folks on Monday? I forget who I asked what again. So just interrupt me if I've already said the story before. But any of you do anything outside of school that you're good at? Any like hobbies? Sports? And how'd you get good at sports? You practiced, right? You don't just be like, oh, I want to be a football star and go out and kick a soccer ball. Do they call it a football? So we call it a soccer ball because we play soccer. But if you call it football, you call that a football? Okay. You kick a football around like, and all of a sudden you can bend it like Beckham. Is that still a thing? I tried it once. I was like, that looks easy, right? No, I don't think that's easy. I don't know how the man does it. Right? Can any of you guys do that? Can any of you bend the ball when you kick it? Give it like it's enough spin, right? It's just physics, right? You just give it enough spin. That's crazy. No, but you got to practice, right? So we're going to put the time in. We're going to practice. You have so many opportunities to practice that you even get points for practicing, right? Go and do the labs. Looks like 5% of people, so like two of you, have gone through chapter 3, right? Is that two of you or so out of almost 30? and no one's touched the labs yet. If you hate Xylabs, I'm with you. I understand it. Okay, they're not fun. It's not meant to be fun. It's meant to be practice, right? It's to get your repetitions in. That's why we've got a lot of them here. Okay, if it's taking you more than 12 hours a week to get through these, let me know. I can tweak them if I need to. Um, but in general, it should be the right amount of effort for you here, right? So if it's taking you hours and hours and hours to get them done, yes, it's supposed to. If it's taking you 20 hours to get them done, no, something's going wrong, right? You know, there's a good few number of hours to get through them here is to be expected. So don't get behind. Again, coming up the following Monday here. So Monday, I put the date in Canvas here, didn't I? The 15th, thank you. So 11:59 p.m. So ideally you're done Monday because we're starting on the next stuff on chapter 4 on Monday. But if you need the rest of that day, sure. Um, and 11:59 p.m. is the default. If I want to change that to another time, I have to click some buttons. And you've noticed by now I'm kind of lazy. I like defaults, right? So it says default's 11:59 p.m. I'm going to take 11:59 p.m. Okay, so get that in, get your percentages up here, because part of your score comes from completing the Zybe, right? So get in and do them. How are we doing on the labs? 6% of the labs done. So two of you have done the labs from chapter 2, and we're on chapter 3 now. Right? This ideally was last week. Again, we're sort of a slow start because of there's sort of a half week here. 46% did the labs here for the first one. Great. Uh, these were super easy, right? Anybody who did these labs? It was chapter 1. Like, these were not very interesting labs. It's sort of, here's how Xi Labs works, right? Go try one. Go try one. Okay? These will take you some time. I'm trying to give you a lot of warning here. Put the time in. It'll go well. If you get stuck on these, reach out. Let me know. Happy to point you in the right direction on these here. We can get you moving. Okay? But we are going chapter by chapter by chapter. We're going to cruise through here. We'll spend a little bit of extra time on loops when we get there because there's a lot of things we're going to do with loops. Loops are a lot of fun. So we'll spend 2 weeks on loops, 2 weeks on functions, but then we get another chapter, 2 weeks on a chapter. When we get to 8 and 9, we're going to tackle not super deep. These are topics that are going to come back up in CIS 200. So it'll happen in a lot of your classes. It happens in math classes, happens in programming classes. We'll talk about a topic, and then your next class, you'll go deeper into that topic. So that's sort of what we're doing at this class. You'll do the same thing in 200. You'll get into a couple advanced things that you'll pick up even further along, like in 350, that sort of thing. So we'll go through the chapters. We're not going to go into necessarily everything in them here. So we'll spend a little bit lighter weeks there. But essentially, we've got 9 chapters worth of work here. So we're kind of blitzing through the first 3 because these are foundational. We can't do the other stuff without them here. And then we'll spend a little more time in loops and in functions. Streams is a lot of fun. We'll do a lot of stuff with streams. We'll use that in our projects as well. Arrays and vectors we'll spend a lot of time on. These tend to confuse people. Just the syntax is super weird when we get to these. It's okay. It's just going to be weird. We can Google it if we need to. We'll get used to it. Pick up objects in classes, pointers, have break, review time, catch up on anything we missed. If something needs to shift, we can hold it for a little while here. And then on the 8th, time to work on your final project. And then ideally, again, you're done by the 8th because you probably have some other classes and not everyone has the philosophy that you can just turn in the project. Really, I don't even know what you do for a history class project. Like, how do you show you've learned the history stuff? Maybe you could do a presentation. I'm not sure, but I think you still get final exams where you have to memorize a bunch of crap and take a test in 3 hours, right? I think that still happens around here. So if you're done by the 8th, that's fantastic, right? We'll have almost a month to get it done, and then you have nothing to worry about for this class. Here, you can focus on your other final exams. When you guys come in on the 15th, you'll just run it and show us it works, answer a couple questions about your code, and it takes maybe 5 minutes, and then you're done. And everyone's going to go through it. No one likes public speaking. Well, most everybody doesn't like public speaking. You'll get used to it. It's a skill you want to develop because you want to be able to present your ideas to your team. It's really sad to be the only developer here and not have someone to bounce ideas off of. And at the junior level, you're probably not going to be like a solo IT department either because you have no idea what you're doing, and that's okay. So you'll probably work in a company with a larger IT team, software team that you can work with and present your ideas to before you move on to other things. So um, good habit to get into developing some of those soft skills, presenting, talking, getting comfortable with it. It's okay if you're not comfortable with it. You'll get it after doing this for almost every class. You'll present something. So uh, hopefully you're here in college to learn something. Maybe. I get we sort of need a piece of paper nowadays in this environment, but ideally you learn a couple things along the way that are useful. So that's sort of the goal. All right, should we go write some more code? That's the exciting part, right? You all came here for code. Um, all right, so far we did not do ranges. So we did like a 1, 2, or 3. We said if it matched that, if it was or wasn't. Now we looked at a couple relational operators. How do we relate, right? Greater than, less than, equal to's, not equals here, right? Does it not equal something? Does it actually equal something here? So the switch statement, again, I'm not fond of these. I probably will never use them here. They're not great if we have to do a range of values here, right? So I'm actually going to start back up at the top. Is that okay? So you open up the same week 3 file, so we don't have that many different ones to go through here. So I'll put my stuff at the top. Otherwise, I have to run through all the previous things, and that got tedious last time. Anyway, so if we wanted to determine, how about we take a score and turn it into a letter grade? Because everyone seems to love letter grades. Right? I mean, no one really loves them, but that's the focus, right? Um, Turns out anytime you measure something, that's sort of what people focus on. So if you get into engineering management, measuring the right things is really important because that's what your staff is going to focus on. If you start measuring that and rating people based on some sort of metric, they're going to focus on that. And if it is something stupid like how many lines of code can you write, then I'm going to be able to write twice as many lines of code and we'll do the exact same thing. Right. So you've gained nothing by measuring that. It's sort of a stupid metric here, universally understood to be a stupid metric, unless you're Elon Musk, who apparently thinks that's the greatest metric in the world. He's a moron, but that's okay. Right. So let's do a range. Right. So let's say no, probably a double. Right. Because you might have like 92.3% or 92.5, and you're like, oh, zero point 0.5 should round up. Here, like, well, I mean, what does it say in the scale? Usually I round stuff anyway, but so we'll have our double for a grade. No, percentage, right? Percentage here, and then we can ask them enter your grade percentage. Sure. Now, if you ask a math person for a percentage, are they going to give you 92.3 or are they going to give you 0.923? You would enter 92.3? Okay, you're not a math major then, right? Okay, that's all right. So I think most math majors would say 92.3 is a percentage, right? Because that's what that is, right? Not 92.3%. That's okay. So we'll probably assume they'll give us a number 1 to 100, right? Because that's what most normal people would do. Not everyone likes to be weird. So we can assume then, so we can input into percentage, right? C into percentage. It's probably going to be a number 1 to 100. Right? Life should be good there. So do you want to start with failing or do you want to start with A's? Because we're going to start at the top or the bottom. We'll work our way through the range. Start from the top. Oh, I heard top. Sorry. So we'll say, okay, if then my percentage is greater than, and I should actually look and see what the scale is because I don't forget, 94, right? So if we're 94 or higher, right? So 94 or equal to 94, then we can see out you have an A. Maybe no exclamation marks. That's okay. Now, there's no range here, right? This is just greater than 94. We're not checking anything else. Other ways we can do this then, right? The smarter way to check the range now would just be else if. So if it's not more than 94, well, what's the next one I need to check? Okay, well, is it more than a 90, right? Greater than or equal to 90. Because I can't get to this line of code if this was true. So I know it has to be less than 94 to get anywhere near this line of code, right? When we chain these things together, they're mutually exclusive. So I have an implicit range here, right? We know it can't be more than 94, right? If it was more than 94, we would have stopped here. So we essentially have a range. So it's the same thing then as saying, so it's the same as if my percentage is less than 94, right? Because we want, if it's not this, right? So less than 94, right? And then we did our ands, right? So if it's less than 94 and something else is true. So less than 94, 2 ampersands, and percentage then is greater than or equal to 90. So chaining them together gives us the exact same result as having one if here, right? Because I know this one can't be true to get down here. So it just saves us a little bit of time to have that range here because I already checked higher. Now we're at the next one here. Right? So we can see out A minus. And this just gets to be a kind of a tedious copy paste exercise here. So we got a B plus, a B, a B minus, a C plus, a C minus, a D plus, and a D and an F. Is that probably the right number of them? And now we just have to go change a bunch of stuff, right? All right, so now we're looking for 87 for the B plus. So we go back here and we'll put a B plus. And this is if you're 87 or higher, right? And now are you 84 or higher? Okay, so 84. 97. Oh man, yep, that's a typo. You would not end up with a B plus. So we're ready, much to go. We're going to test it in a minute. Yep. So if you can catch it before you even hit run, you'll be a lot less confused. B minus, and then we go down to if you want 77, right, for a C plus, and then 74 for a C, 70 for just a C minus. And where do we go? C minus, 67 for a D plus. Oh, this one even has a D minus. Oh, I didn't know there was a D minus. Okay. 67 for the D minus, 64 for a D. And now, if it's not one of these here, right, I don't even really need the rest of a range here. I can just have my default, right? You fail. That's the sad letter. Right? No one wants to fail. It happens sometimes. It's okay. It's not the end of the world. You can take the class again. Um, so we have implicit ranges here. Works out pretty nice for us, right? Now, other ways of doing ranges, right? This is nice and efficient, so this is ideal, assuming we've done it right. Because it's going to check the first one, and the next one, and the next one. One of them should match, and it's within that range that we've specified, because it can't get to these lower ones unless the upper ones aren't true here. But we don't always have like this exact sequence, or maybe we don't want to do it in this exact sequence here. We don't have to do it this way. We can get the exact same job done differently using multiple conditions, right? Using a little bit of logical operators like ands and ors. Ors probably aren't going to get the job done here when we're detecting ranges. But maybe we also then want to say at the beginning here. So we enter the percentage. We can say, hey, if your percentage is less than 1 or your percentage is more than 100. Right? These are like invalid ranges. So the or here does make sense, right? You can either be too low or you can be too high, right? I can't have both of them true at the same time, so I can't use an and, because you can't be too low and too high at the same time here. We can just tell them, hey, you did it, you gave me a bad number here. Invalid percentage. Enter 1 to 100. Now, we haven't got to how do we make them enter it again. I guess we can CN to percentage again and hope they give me the right thing, but nothing stops them, nothing keeps them in here. So we've at least tried once. Again, we'll come back to this next chapter. Do better next chapter. And we'll do better next chapter. But for now, that's okay. We'll just ask them one more time. So we'll enter percentage. So if they gave me 0.293, like a math major would when you ask for a percentage here, right? Obviously, it's not a whole number because it'd be, what, 9,000%, right? So 0.923, and we're like, oh, no, that's invalid. Enter 1 to 100. Well, maybe you should have told me 1 to 100 to start, right? Like, help your users out. Tell them what you're expecting at the beginning, and you might get some better input. Not guaranteed, but probably get some better input if we ask for specific numbers here. So, I mean, it works the first time, and then sure, now let's do like a 91, and we got an A minus, right, like we expect. Now, it's going to take a little while here, but we probably want to test all of those ranges out here, because if it's important that it works, we need to make sure it does what it's supposed to do. Because like you saw, it's really easy to typo things. I totally did that on purpose to illustrate how easy it is to typo things, right? That happens. And just like an English paper, we know what it's supposed to say. So when we go and proofread it ourselves, we're like, oh yeah, I'm sure it's fine. I meant to not have the word the in there 3 times in a row, but somehow I typed the 3 times in a row. That happens. So we're going to run it and test all of them out here. which is kind of obnoxious, but that's okay. So 95 is an A. We did an A minus. Now we need to run it again for a B plus, like 88. Get a B plus. Stop, run it again. Let's try a B, like 85. Sure, B is good. Stop, run it again. And you get the idea. This kind of sucks here, right? But it's good because we want to make sure if we wrote the code that it does what we told it it's supposed to do here, right? Because it's possible to make mistakes. It's likely to make mistakes, right? That happens. So the only way we know how to check it is by trying it, right? We know what's supposed to happen. If I put this in, I get this out. That's our fancy term for algorithms. Right? Everyone loves the word algorithm. Such a fun term here. But that's all an algorithm is. If you put something in, you know what's supposed to come out. The algorithm is what happens in between. Okay. So if we're trying to solve a problem, and I know, hey, when this goes in, this comes out here, we have to write the algorithm. We have to figure out, okay, here's how you do it, step by step by step by step, to make sure a dumb computer can solve it. Right? Because that's all computers are going to do for us. They're going to do this step and do this step and do this step and do this step, just like we tell it to do. Right? So again, nothing super interesting with this one here. But now maybe we get into some more interesting pieces here. So let's try and take something that's in the news. Should we try and calculate tariff rates? Would that be fun?
Sure.
Calculate how much we're going to pay for tariffs. Just a pop quiz because you're all intelligent people in college. Who pays a tariff?
The customers.
Customer of what? Which customer?
The product. I mean, basically, they're trading. The person who manages the trades, he pays a surplus on that.
So
And
the
he has to
customer of a
charge.
foreign product.
Yeah.
Yes. Okay. Thank you. Thank you for being specific. Yeah. So the person importing, the importer, okay, pays the tariff. Uh, great. It was recently in the news that if tariffs get overturned, if the court decides that the president didn't have power to unilaterally impose tariffs, they're going to have to refund a bunch of money. That's sort of how that works. I don't know why people are surprised about that, but okay. So let's calculate that. So at one point, there used to be an exemption for low-priced goods. There's a certain amount of goods you can import without paying any tariffs, and then if they get higher, then you pay more tariffs, right? So we need to have some sort of range here. So I don't actually remember. Let's set the small tariff exemptions for small orders. I forget what it was called here. There we go. For $800 or less. Oh, it's gone now. Of course, that's helpful. We'll pretend like it's still here because who knows? And that would make the example really boring otherwise. So if the order is $800 or less, we won't have to pay any tariffs. Right? We're protecting the small importers or people want to spread their orders. I don't know, however this works. Sure. So we'll have a tariff order minimum. What do we want to call that? Minimum tariff order minimum. Sure, we'll set that at $800. Now, if I want a value and it's not supposed to change here, right? I don't want to change this one in my code. We want to make this constant. So we've got a way to say, hey, keep this value from changing. So we tell C++, I want this to be a constant value. And for some reason, we don't like using the last couple letters. We drop constant, we drop the ger from integer. Sure. So a constant int, tariff order minimum, and then if it's a constant, you can name it this way, but it's frowned upon. Right? We love visual cues. We love conventions to give us information about our variables just by looking at them here. So I'm going to change this and call it tariff order minimum. Minimum. Sure, that's probably close. So if I do all uppercase and then I use underscores, because if you run them all together here, it's terrible. So we have to have some way of separating our words here. That's tariff is spelled wrong, isn't it? Two F's, right? Two F's. There we go. Tariff order minimum. Now, it's visually striking, looks different here, and the convention is this is a constant value, don't go change it. But now I don't need to go look somewhere else in my code to find out this is constant. I just by looking at the variable name, I'll see it here. Okay. And then we'll ask them for, so we need a double for order cost, and we'll see out, enter the cost of your international order. So we can calculate tariffs. 1R? 2Rs? I really can't spell. My apologies. 1R. Okay, that's what I thought. 2Fs. Tariffs. Okay, and then we can see in on our order cost. And now we're also going to need to know what country this order came from. because someone with a spreadsheet decided we should charge different countries different amounts based on the trade deficit, which means we want to buy more of their stuff. We're currently buying more of their stuff. Sorry, this is not an economics class, but this stuff is interesting. Um, so the trade deficit means we buy more from them than they buy from us. So we want what they're selling. They don't really want as much of what we're selling. That's what a trade deficit is, right? So for some reason, we decided uh, I should exclude myself from we. That sounds awful. I didn't decide. Some people decided that just because we buy a bunch more stuff from this country, that we should have to pay more money for it because there's a trade deficit. So we're going to tax imports from that country higher because we really want their stuff. That makes lots of sense, I'm sure. Um, I've got a dear friend I work with who's a PhD in economics, and she gets visibly angry when we talk about tariffs, which is a little bit amusing. I try not to bring it up too often, but just like usually, like she gets real angry about it, which is it's amusing, right? Do you ever do like irritate your friends on purpose? Like that just irritates them. They're gonna go off. Like okay, so then we'll ask what country it came from. So we'll have a string for the country of origin, and then we'll ask what country did this order come from, and then we can see in the country of origin. All right, now we need to see what our tariff is going to be, right? So we paid the company whatever amount of money was our order for it, and now how much are we going to pay the feds? What's their cut on this order here? So it's based on if the order is less than $800, right? So if my order cost is less than $800, see out no tariff at least 2 weeks ago. It wasn't. It's changed since then, but again, that's I feel bad about my example changing. This is going to be a lot more fun here, but that's okay. So if the order cost, now what else, right? Okay, well, else if, right? If it wasn't less than $800, if my country of origin then equals USA, and this was one of the whole premises, right? If you buy domestic, there's no tariff. Yeah, sure, okay, that's a fair premise. Um, no tariff. It wasn't imported. Unless you are Chrysler and you liked your slogan of "imported from Detroit." Which that was a kind of a good slogan, actually. That was kind of catchy. I thought. I remember that they ran. There was a commercial in the Super Bowl for like the Chrysler 200 or something. It was a couple years ago. I'm an old person now. You guys don't remember anything, and I do. I swear. Okay, hang on. Let me see when that was. Imported from Detroit. Ad. When did it run? 2011. Oh my goodness. Goodness, really? I still remember that. Like it did really well for them. Like it was a good campaign. Okay. Wow. That whole ad, it was a really good ad. I mean, I don't know. It had like highlights of cool pictures of stuff in Detroit. Um, okay. Never mind. Sorry, my sugar's high. Why is that beeping at me? So I stopped for breakfast on the way here. It's my fault. Let's go a little more insulin. All right. All right. So now we need, so if it's not that, then, so else if, now we need to start looking at, let's just look up a couple tariffs. So tariff rates by country. Here we go. Passportglobal.com. I don't know if tariffcheck.org. Tariff rates, world population review, Wikipedia. I don't even tariffcheck.org sounds okay. I don't know. It doesn't actually matter because we're just pretending here, right? So, all right. So, if we're buying from India, it's 25% tariff. Because we like to buy a bunch more stuff from them than they like to buy from us. Of course, we should punish American consumers for buying goods from India. Um, uh, I have opinions about this. I'm sorry. You probably noticed by now. That's fine. We'll try it here. So, if the country of origin, then country of origin is equal to India. India. There we go. Right? We know the order cost has to be more than 800 already. Then we can see out your tariff cost is, and maybe we'll add a dollar sign, make it look pretty, right? So it's the order cost times. Now, oh my goodness, I did a bad thing here. I came up with this tariff order minimum and I didn't use it here. I'm just realizing here. Now we probably need a constant double for tariff rate. I don't know. Tariff rate. India, 0.25, right? So order cost times 0.25? Sure. And we'll have a bunch of different ones. Oh, for Brazil, 50% for Brazil.
It's 100 in India.
I'm sorry?
It's 100% in India now.
It's 100. So this website you're saying 2 weeks ago is out of date? Yeah, because trade policy should definitely change every week. That's helpful for international trade, I'm sure. Goodness, I'm sure there's an economist here who's much smarter than I am. Go talk to them; you'll make their eye twitch. But go ask me like, "Hey, my CIS prof is telling me about tariffs." The eye will just start twitching. It'll be funny, but they can inform you. 100% now. Okay, so look, we can change it in our code. Now, look, we've done it. So, having a constant here is kind of nice. We'll put it in here. That's fine. Um, sure. Tariff rate, and then an end line. All right. And we have to go through, check a bunch of different countries. So it's going to be a little tedious, right? There's, um, interestingly, I see number of countries in the world. Hang on. Before I say a dumb number and look stupid here. How many countries are in the world? I just want the number here. UN members 197, independent states. I think that's the official number we'd like to go off of, right? So less than 200, right? Do you remember how many trade deals were promised? More than 200? Anyone remember that? Okay. So we could go through and have a list of 200 countries, 197 different countries, and have a different tariff rate for all of them. And some poor person software has to have that. It's not the end of the world, right? It's 200 lines of code plus a bunch of checks here, right? We could do it if we wanted to. Do we want to type it all out today? No. No. This we've illustrated here. Let's do one more. So else if country of origin, we'll do Brazil, right? Because they showed up on the list. Country of origin is Brazil. Then we probably need a Brazil tariff rate. Tariff rate for Brazil. That was 0.5, right? Just a measly 50% tariff. We're not doubling the cost of anything. That's just 50% more here. So sure, so we'll copy that one, and we'll just take my tariff rate for Brazil. Okay. Yeah, I think you get the idea of how we could calculate these here, right? Checking, looking it up here. And if you're thinking there's a better way to do this, yes, we just haven't got there yet. We'll get to better ways of saying, oh, if this is a country, here's a rate. If this is a country, here's a rate, like sort of mapping that data. Yes, there's way better ways to do that here, I promise. We just haven't got there yet. Okay. Um, is there a way to calculate the tariff cost of an order? Free tariff calculator, gettariff.com. That's kind of what I was looking for, actually. Let's see if the website's any good here. Note the total cost before you buy here. Product description. If we want to like drop ship stuff, right? We'll just order a bunch of crap and then resell it, right, under a different label. I guess that's not exactly drop shipping, but something similar, right? So we'll say it's from China here. We got a bulk order of. I've been buying a lot of these fly swatters here. It's I can't. It is typing. Okay, fly swat. It's just typing in a light gray. That's really useful user experience there. Like, can you guys see how light gray that is? It's there. It's typing. They didn't give me my regular black font. I don't know why. And the import value, we'll just say this is $500 here. Calculate tariff costs. 25% tariff rate here. How did that get to 500 to 900 with the 25%? Okay, I don't. Oh, it gave me a shipping estimate. Oh, look at that. Product cost, that how much they're going to charge me to ship it. Port and handling, getting it actually handled at the port. Okay. They're not going to ship it right to me. I don't buy, you can tell I don't buy things all that often that aren't from Amazon. They take care of all that for me, right? Um, look at that. Save and get a full report. Share my results. All right. So we could write our own calculator. Right. Feel pretty confident? Okay. Ranges. features, branching, whole calculations, order evaluation. We did order evaluations. We complained about that a lot. Good. All right, you want to hear that again? It switches the Boolean data type is really cool. We do that. We talked about that, right? It can be true or false all by itself. If you're hungry or not hungry, bless you.
Right.
And that's just a Boolean value, so you don't need to compare it. Right? You don't need to say is true equal to true. You just put your Boolean in here. That's the implicit this is true, because if it's not true, it doesn't run. Uh, yeah, Boolean values, the conditional expression. This one's a lot of fun here. And by a lot of fun, the syntax is terrible. I don't ever expect to see freshmen write it, and usually when I see them, I have a pretty certain feeling that they didn't actually write their code because they copy pasted it from online. And ChatGPT loves Boolean expressions. I don't know why or what code they copied off of here, but it loves these, and we'll use them all the time. Right? And they're obnoxious. So a conditional expression here. Now, this actually works out kind of nice here. So we can have instead of like outputting here, what my values are here, let's have a tariff cost here. So we'll have a double for tariff cost. And now we need to go set that value to something, right? So instead of outputting it here, right, or maybe we'll do both here. So we'll set tariff cost. Yeah, let's just set the tariff cost to 0 here. And then we can output at the very end what the actual cost is. Tariff cost 0. Tariff cost is this calculation here. Right? Tariff cost equals, we'll assign it the value that we're calculating from here. 2Fs there. And then one more time, we'll assign it the value we're calculating here. And this is pretty good, so we don't have a bunch of duplicated code, right? We're just calculating what the tariff is, and then at the end we can see out your tariff cost is $, and take the tariff cost. Tariff cost. Okay, we can do it this way, and that probably looks a little bit nicer. We'll add an end line. We don't have to have 50 different or 197 different prints here, right? I'll just have a cout once, and I'll have 197 different calculations. Sure, that should be easy. Now, this gets to be more complex depending on what the type of good is here, right? Because we have different rates for different things, or if you have to be Apple and have lobbied the administration to let your products not be tariffed here because you have a lot of money that you can donate to the president, you can get an exemption. I mean, for strategic reasons, U.S. national interests, I'm sure that's why Apple got exemptions, right? What's the official line? I forget. Um, you can get exemptions. It has nothing to do with them donating lots of money, I'm sure. Absolutely nothing related to that. Now, it's warning me here, saying using uninitialized memory, which is kind of a weird error, but you remember you declare values and then you initialize them, you give them a value here. So we declared a value called tariff cost, but it's possible none of these ran. And C++, the compiler, is telling us, hey, you might not have set this to something, right? Which I think makes sense here, because it's possible this didn't get set, right? So different way of calculating this here is something we can do. So we can check to see, or maybe we can either give it a default value, start at 0, or we can use that conditional operator. So the conditional operator is ugly, but it's okay. So let's give it a try here. So instead of these ones here, let's go, I guess we have to use it in here, don't we? No. Let's go set it here. So let's say my tariff cost is equal to, and now I'm going to give it an inline if-else expression. These conditional operators, they let you give an if-else inline. So it's essentially, if something's true, here's a value, else here's a different value. Right? If that's all we're doing with an if-else here, then I can do this right in line here. So we'll say the tariff cost is, and then I give it my expression. So this is my total order cost less than 800 then. And then we give it a question mark here is 0 colon order cost times, let's go with the tariff rate here. I don't actually have this set yet. Let me do one more variable here. So double for tariff rate, then we'll start it at 0. And then I'm going to set the rates here this way. Tariff rate, the tariff rate. So now we get this garbage line here. This is a conditional expression. So here's the condition. If it's true, we get this value. If it's not true, the else, we get this value here. And this is why I know people don't write them, because these are awful looking, right? Is this helpful at all? No, but look, I've written less code, and it looks fancy. I saved 5 lines of code. You know, so it's the exact same thing. We could say if my order cost is less than 800, then my tariff cost is 0, else my tariff cost is equal to the order cost times the tariff rate. Okay? 6 lines of code, 1 line of code. Sure, we're much more efficient and fancy. And now you might have seen in Zybooks, and you might have had someone tell you these curly braces are optional, which is technically true here. So sure, if you want to save one more line of code here, or two lines of code, right, we can do that with an if and an else this way. I would strongly discourage you from ever excluding your curly braces here. I think it's a terrible practice. Some people love it, and I just hate it. And I remember this was a very long time ago, probably before some of you were even born, because this was when I was in high school. Um, the Safari browser had an issue where the SSL security broke. There was a way to bypass the security, a vulnerability. And it was related to the developer not using curly braces here because they had 2 lines of code here, like something else was supposed to happen. Like, I don't know, tariff rate equals something else was supposed to happen. If you don't include curly braces, only the first line runs here, and now nothing else is the else is detached. It doesn't even work here. So I think it's probably in their else block here, right? They probably had something like this. I forget exactly what it was here. So it looks like if this is true, this part runs, else this part runs here. But without curly braces, this line will run every single time, 100% of the time. It causes an issue. So just always use your curly braces here. Um, I promise it's a good habit here. When you go get a job, if they tell you you don't always need to use curly braces, just smile and nod. Right? You don't. It's not worth arguing about here. But I would assert it's terrible practice. And you don't even have to type them. Like it generates them for you. You're not saving any time because then you have to go erase them yourself. Like you've taken more time to go erase them and you could have just left them here. Because any good IDE is going to make your curly braces for you. Okay. But this conditional here is the same as an if else. So all it does is take this value or this value here. And the reason why I hate them, because I can never remember, do I put my question mark first or my colon first? That's really the entire reason I hate them, right? Because I don't remember which one you're supposed to put first. And if I have to go like look it up here, I've wasted my time when I could have just written an if else here. And I feel like these look better. Now, you can also do terrible things with conditional expressions where you can have a conditional inside of a conditional here. And at this point, you're just trying to hurt people. But you can. So we'll say, okay, if it's less than 800, there's no cost. Then otherwise, then we'll say if my country of origin is equal to Brazil. I can't spell Brazil. Then we want to give, I don't know, like just don't bother. It's not, no one wants that. So don't stack them here. Uh, you can have ifs inside of ifs, else's inside of things. Just do it this way. Life will be a whole lot easier. So the conditional expressions, um, strings are fun. This is a fun piece here. So we can look to see if something is inside of a string with the find function here. Now, if it's not found, it gives us this string n pos, no position is the little caveat here. So want to see, hey, is there a particular value within a string here? So we'll ask someone maybe, how about a string for an email address? Okay, and we'll ask them enter your email address, address, and we can see in the email address, and then let's check. So we want to say, hey, if my email address dot find an @ sign, right? Looking for an @ sign. If the find of that is equal to string no position, not found, that's probably invalid, right? So you got to have an @ sign in an email address. And this is a terrible way to check if it's valid or not here, but we can check pretty quickly here if we found it or not, right? If we did find it, right? Else, if it's not npos, then we're going to go find where it is here. So we can get the my index of sure, is my email address find. Okay, so that's going to tell me what position it's at here in that string, which is a lot of fun. So now I can go and do something with that information, right? I can go get pieces of that string up to that location, right? If I wanted to split it on what's your email address and what's the domain here. So we can find it, and then we can go get it out. Oh yeah, here's the @ sign. There we go. Told us where it was. We can go get a piece of a string here, a substring. So I want some number of characters out of that string. So when you ask for a substring, right, so we'll say, I want the substring from something to something else. Forgot this was already an example in there, my apologies. But it's very exciting, right? So their username, or the user part of the email, is, and we'll take my email address dot substring, oops, plus, there we go. No, this one. Email address dot substring, so sub str, and we give it, this is kind of ugly. Let's give it, how many characters do we want, right? Well, I want whatever the index was here, right? So start at 0. So starting at 0 is the start of our string up to here. Give me those many characters, right? And then the domain part of the email is starting at, so substring starting at that index plus 1, because I don't want the @ sign. I want to go 1 past the @ sign, right? And then I want to go, how many characters? Well, I need the length of my string, right? Oh, goodness. Oh, okay. I can just start at the end here. There we go. Let's save a little bit of typing here. I can cheat. We don't even need to find out how many characters. So let's try my email address, see if it works. Jonas at umich.edu. So it's going to go find the @ sign. So this is index 0, index 1, index 2, 3, 4, 5, 6, 7, right? 8 letters, right? So then here's the index of the @ sign is 8. It's the 9th character. So everything up to there is eTRNS. Everything after the @ sign is the umich.edu. Very exciting. We've split it here, but being able to check to find these indexes in a string is really nice. We can look for specific pieces in our string as we go here with the substring. So you can get start at a position, this many characters, start a position, this many characters, or start here to the end. Right? So different ways of getting that here. Now, finding a character, right? Where do we find that character? The size of a string, -3 will get you the last 3 characters, right? So if you take the size -3, so start at the end, go back 3, and give you everything to the end. You can do some fun things with it. You can replace characters in a string, right? You can insert characters in a string, which is a lot of fun. So we can manipulate these to do any sort of fun stuff if we want to. So let's go and should we replace here with some new text? Maybe we can go and encrypt our string here, have a little bit of fun with it. So we'll ask for some message. So we'll have a string per message. And we'll see out enter a message to encrypt. And then we can see in on message. And actually, encrypt is really the wrong word here. We're just putting it through a cipher here. But that's okay. So we'll take that, and now we want to go start replacing a bunch of characters here. Now, this is going to not work well if I replace a character with a character, and then later on, so if I replace all the A's with E's, and then later on replace all the E's with another character, well, I've now changed the A's to E's and now the E's to something else. So we need to like make a copy of our string first or do something else with it here. So what I would like to argue is probably just a quick, easy way here. Let's start with lowercase and replace it with uppercase letters. So that way I'm never going to replace uppercase letters. Right? That should make life a little bit easier. So if I want too lower, oh goodness, how do I do that? Hang on. So lower is lower. No, message dot. Oh my goodness. There's a way. So I really have to do it one character at a time? I might have to do it one character at a time. That's ugly. I'm just going to Google C++ lowercase string. I thought there was a way here. Two lower. Yeah, okay. Two lower. That's what I thought it was. Standard library two lower. Oh, I tried lower. I didn't try two lower. Sorry. Message to lower. There we go. So we'll just take our message, assign it to the to lower of message. Message. Is that going to do it for us? No, doesn't convert. Does it do one character at a time? Okay, I guess we did the wrong thing here. For each. Oh my goodness. That's converting a character. I want to convert the entire string. All right, we'll do it one character at a time, I guess. That is terrible, and I'm sad now. That's okay. Other languages have much nicer tools. C++ is a little bit annoying. So we want to go through our message here, and we want to take the character and convert it. So we can get out individual characters out of our message. So we'll just make a new message here. So we'll have a string for the new message or encrypted message. Message. Then it's going to start off as nothing here. So we'll start this off as blank, and I'm going to grab the characters out of this one and add it to the encrypted message. We'll do that here. So we'll go through and convert them. So I can take the encrypted message and I want to add to it here. We'll say it equals the encrypted message plus, I'm going to take my message. If you want to get one character at a time, you can use this little at syntax. So I want the character at 0 here. So we'll grab the first character, and then we want to convert it. Right, so we want to change it to something else here. So if we want to change, let's see, that gets me one character out. Let's try, is it, no, oh goodness. If we don't have loops yet, this is much harder. I'm sorry. This would be much more fun if we've gone through what loops are. Goodness. I don't want transform. I want the loop. To lower. Yeah, we get that one. None of those are fun here without those. We'll just replace. All right, that's fine. Message dot replace. What do we want to replace? All right, so when we're replacing here, this gets a little bit awkward as iBooks go here. We can use our replace. So we want to replace what? What address are we going to replace? With what value? So from 0 to 3, we're going to replace it with this. We could replace, goodness, length of 3. So from 0 to 3, replace with 3 characters. Right? Or we could replace one character at a time here. Where's our replace lane with ln, or shortcutting? Very exciting here. We just want to replace one character though. So we want to go find, right? Should we maybe find the e's and change e's into something else? So we want to replace what? So let's take our message, find an e character here, and we want to replace it with, what should we replace e's with? With z's? Oh my goodness. It's not going very well, I'm sorry. How many characters long? Just one. One character long. Replace e's with z's. And then message.replace, message.find, a's with, what should we replace a's with? A b? Sure. Replace a with b, e with z. All right. And let's see out our message. If we didn't make a copy, that's fine. We didn't make a copy. It's going to be a little bit ugly. Ooh, maybe we could make a copy. That's fine. Let's give it a message. See if it replaces them. So what word has an A and an E in it? What?
A and E, apple.
I'm sorry.
Apple.
Apple. I'm sorry. I have a hard time hearing. Apple. All right, so we get E P P L Z replaced. Thank you. Right, Apple. It replaced our letters. Again, this runs into the issue though. If we actually had a Z later, wanted to replace all of them, this is going to get a little bit messy. we can come up with better ways to do it once we've looked at loops. So next week we can do much more fun ones here. My apologies. Um, this is a little bit boring without a loop because now it's only going to replace the first E as well, which is a little bit of a bummer. Now, if we don't have those letters, right? If I gave it like banana, that's got an A, but there's no E, we get invalid string position and our program crashes on us and we're sad. So each of those should probably have a if it does not equal an end pause, right? Then we go do it. So if we have an E, right, in my message, then we go replace the E. But if I had more than one E, well, I could just copy paste this a couple times, I guess. Like, hey, maybe there's three E's in there. I don't know. This is looking terrible here. Feels bad, needs loops. So we're not there yet. So we can just, do it 5 times and feel bad about it, and that's okay. There's got to be a better way. Yes, there's a better way. We'll get to that better way. So we can replace all of them here eventually. Replace all of them here as we go. All right, how good are we doing on chapter 3? I think we've got through almost everything. Short circuit. This is a fun little piece here. Because of the way our logic works, C++ is lazy, or they wrote it to be efficient here. So if you're anding things together here, the first time C++ sees a false, it stops evaluating. Because you said, if this is true, do something. And as soon as it sees a false and it knows it's anding, it doesn't care if the next thing is true, the next thing is true, the next thing is true, the next thing is true. If the first thing is false, the whole thing is going to be false and it stops. Right? So it takes a little bit of a shortcut and does that short circuit evaluation here. So like 10 plus 4 greater than 15, we know that's false. This never even gets looked at because it's false. Okay, so short circuiting saves some time here. Comparing floating point numbers gets to be a pain here, and you got to be a little bit careful. Remember, because math is bad, or C++ is bad at math, and we have these like little bit of trailing decimal places here. So what we want to do is use the absolute value here and check is the delta small enough, which is not the end of the world, but we can check here. So we'll look at one of those real quick because that's fun here. So if we wanted to say, let's have the user enter a number maybe. So we'll say an int for the denominator here, and we'll see out enter a denominator. And we can see in the denominator, and then we can say the result, or that's a double result, is 1 divided by the denominator. And then if we wanted to say, hey, if the result is equal to 0.33, 3, so like if I happen to add a third here, right? See out, you entered 3, else you didn't enter 3. Silly example here, sorry, but we want to look at how we can use that, essentially the delta between the two here. So if I enter a 3, it should be about 3333333. Remember, we're never going to get exactly there. Because if we run this in debug mode, right? So add your little breakpoint in the gray space. The debugger is going to be your best friend, I promise. You want to learn to use it here. We'll calculate what it happens to be. So I put in a 3, and then I'm going to step over to make this line run, right? It pauses here where the yellow line is, and now I can run it one line at a time. So I step over and I can see, hey, result is, uh-oh, 0.00, it's 0. We got nothing. Well, it's not a third, right? The denominator is a third. Should we do 1.0 divided by 3? 3, step over. All right, now our result is 0.33333333331. We've lost some precision here because our decimals aren't great. And we're going to check, is it equal to this one? Nope, didn't work, right? So again, if we want to compare numbers with floating points here, at some point we probably don't care if it was the 15th decimal place, 16th decimal place, whatever happens to be here. We don't particularly care. So we're going to check, we're going to see, hey, is the absolute value of this, and for some reason that's fabs, F absolute value. Sure, if that floating point absolute value, I don't know if that helps at all, but it's fabs of the result minus that then is less than 0.000001 or something like that, right? Whatever my precision happens to be here that I want. So if I subtract all this out here and the difference is less than that, right? So I only care about the first, I don't know, was that 8 digits? 2, 4, 6, 9 digits here. After 9 digits, it's fine if it doesn't match, right? I'm okay with that. So now we can run it and see. I'm going to step over, let's enter denominator, we'll get 3, step over, calculate result, okay. Now we get where we want it to be here. Because we're checking, is the delta small enough here? Were you close enough when you calculated here? Because they're never going to, unlikely that they'll ever match. It's possible they'll match here. But to get the actual whatever we calculated for 1 divided by 3 is going to be rough. So just be careful when using floating point numbers here, because we know the last couple decimals can get screwed up here. I'm going to be a little bit careful with that one. All right, cool. So floating points, ranges, operators, branches, switches, booleans, strings, characters. Yeah, other fun things with characters. This was the one with head lower and upper. You can convert individual characters around. This one's a lot of fun here. I think that gets us through chapter 3. How you feeling? A lot of stuff, right? This was a lot in the first 3 chapters. 1 was sort of a soft start. 2 and 3 are foundational. A lot of material coming at you. Get your reading done. Let me know if you have questions. Happy to help. Don't forget, we started on our project here. Uh, and just a soft start project, not crazy hard. But once we've gone through chapter 3, this should all be doable here. Just some calculations here, nothing too bad with this one. We should be able to go from there. Right, questions, thoughts, concerns? All right, awesome. I will see you folks Monday then. Take care.